So start with, presented are the materials needed and their corresponding quantities which will be used during the simulation. This laboratory activity is entitled Diode 1 to 5 curve. So from here we are given an illustration for the circuit to be simulated. We have one voltage source, one diode in forward bias, and measuring tools such as the ammeter which is connected in series with the circuit, and the voltmeters which are connected across or in parallel with the components to be measured. Now when we have tried to simulated the circuit with different voltages from 0.1 to 0.95, here we are going to find the measured values for the voltage across the diode and its current too. Based from the listed values on the chart, the measured voltages across the diode are equal to their respective voltage sources. The values of the current in a voltage sources of 0.1 to 0.4 are very small since it was measured to have many decimal places or digits. And upon our observation, the values for the current across the diode is increasing as the voltage across it also increases. Based on the graphical representation of the behavior of the diode at different values of voltage sources, the diode's current capability is off at points 0.1 to 0.4 and starts turning on at points 0.6 and above. This is due to the value of voltage sources which have been used on the experiment. When the voltage source has low voltage output, the diode would conduct a tiny amount of current across the circuit. Proceeding with the next laboratory activity, here we also have the materials need and their quantities. And by the way, I have used Electric Studio app in this experiment. To continue, this laboratory activity is mainly focused about the characteristics of a forward and reverse bias semiconductor diodes. Now, shown on the screen is the circuit diagram which will be simulated. First is a circuit containing a forward bias diode, and the second has a diode in reversed bias. What is common on this circuits is that they also need measuring tools which we just have used on the first laboratory that has been presented a while ago. We also have one resistor each which will also be measured on this activity. Now here, we are tasked to measure the voltage drop across each diode and the circuit's current. And also the voltage drop in the 150 ohms resistor. Now after the simulation, here we have the values which have been found on the experiment. One for the forward bias diode and the one for the reverse bias diode. Now, this measured values will also be computed. Using second approximation for the diode which is 0.7 volts, the voltage going through that diode will be reduced to 7. So if we have a voltage source of 12 volts, across the diode it will be 11.3 volts. And rounding it up will be 11 volts. This voltage will be used by the 150 ohms resistor consuming it so that 0 volts will be returned to the ground. To compute for the resistor's current, we are going to derive the formula on the Ohm's law where I is now equal to voltage divided by its resistance 150 ohms. Now the current is 75.3 milliamperes, rounding it up to 75 milliamperes. So if we are going to compare it with the listed values on the table a while ago, they are closely the same or equal. Next for the reversed bias diode. It is believed that no current will pass through it because it behaves as an open line or circuit. So the current across the reversed bias diode is 0 which the current across it will also be 0. But in this case, we have used measuring tools, so we have values for the voltage across the diode and the resistor, and also the current across the whole circuit. So that's all for my video explanation. I am Gerald J.B. Montañez, a BSECE2 student of Bicol University Pulangi campus. Credits to Text Reader app, a text-to-speech reader app which I have used in this presentation. It's easier to use and gives me more confidence in sharing my thoughts. Thank you and that's all.